Hello, today we're going to look at a problem where we're actually going to be using a two-tailed test instead of a one-tailed test, which has been our normal modus operandi up until now. And so what's the difference between a one and a two-tailed test is a two-tailed test is where the results in either of the two directions can be used to reject the null hypothesis instead of just one. So let's go take a look at it. What we're looking at is we're looking at these grocery bills. A study is performed in a large southern town to determine whether the average amount spent on food per four-person family in the town is significantly different than the national average. And that's the key. If you look at that, we're just asking, is it significantly different from the national average? We're not asking if it's higher or lower, just want to know if it's different. So it can be higher or lower, which is going to feed into, we're doing this two-tailed test. A random sample of weekly grocery bills in the town is provided on the next tab. Assume the national average spent on food is $150. And so what we're going to do is we're going to create a 95% confidence interval for the population mean weekly grocery bill. Based on that confidence interval, we're going to ask ourselves, is the town's weekly grocery bill significantly different from the national average? We're going to identify the null and alternate hypothesis, and we're going to figure out, is the sample evidence statistically significant? And so we go right here. There's our weekly food expense. Here is our data, and we've already got it set up to what we're going to be filling out. Right off the bat, the first thing I want to do is I do want to come and I'm going to set my range names up because it just makes it easier to use. And then we'll grab all of these. We don't really need to grab the upper and lower interval, confidence interval, because we're not going to really need those. Now I'm going to come down here. I've got sample size, mean, and standard deviation. They're going to end up being the same as up here, so I'm just going to grab the stuff underneath of them and our hypothesized mean, and we'll create from selection, and we're going to get back to all of those in just a minute. So let's do part A. We're going to go into our confidence interval. So the first thing we do is we're going to find the sample mean, once again just as average, and we have weekly food expense is the column that we set up, so we'll just find the average of that. And there's a typo. Oh, I accidentally put in an extra parentheses. It'll fix that for me. So our average is $159. So on average, we're higher than the national average. But once again, it's all statistics. We gotta do all that stuff. So stdev.s of the sample, and then once again, we're going to use the weekly food service expense. And so we have a standard deviation of $23.936. In fact, that is in dollars too. So let's go and change that number into currency. The variance is dollars squared. The standard deviation, since it's the square root of the variance, will be in dollars. So our sample size, we are just going to count. And we are going to count that weekly food expense. So we have 100 different samples of what we're looking at here. Our degree of freedom is going to be our sample size minus 1, because we just have the one set of data. And now we're going to look at our t underscore alpha over 2 comma degree df for degrees of freedom. So we're going to calculate out our t value. And so we're going to be doing this using our T inverse equation. Now typically we've used T inverse to get the left-tailed response, but we're doing a two-tailed because we want to know what's going on both sides. So we're going to do our two-tail. The probability is 1 minus the confidence interval, and so that is going to give us 5%. Yeah, the stuff on the very, very tail end of things. Tail on the tails just works out like that. So on the very tail end of things, and then we need our degrees of freedom. So 99 degrees of freedom, and so our t value is going to be 1.9842. And so we're going to put together our confidence intervals. So my confidence interval is going to be the sample mean. Where'd it go? Sample mean. Now, plus or minus t times the standard deviation divided by the square root of the sample size. So we're going to do the lower bound here, so that's minus, not underscore, but minus. And then we'll do our t-value. We're going to multiply that by our standard deviation, and then divide that by the square root, the square root of our sample size. And execute that, and so the lower bound is 154, and I'm just going to click, and we're going to roll that equation down, and we will change it to plus all that. So our 95% confidence that any of our values are going to end up between 154 and 164 for their food bill. What does that tell us? That tells us that since the confidence interval does not include $150, interval does not include $150, oops, tilde's in there, $150, which is the national average, we can conclude with 95% confidence that the town's average weekly grocery or food bill is significantly different from the national average. Okay, so that is part B. Based on the confidence interval, is it significantly different? Yes, because it does not fall within that. So let's get to the next part. We need our hypothesis. So let's check our hypothesis. So our null hypothesis, H0, and that's going to be that the mean town is equal to the mean of the national. So our null hypothesis would equal the mean town is equal to $150, because that is what the national average is. So what is our alternative hypothesis? Well, that's the mean town is not equal to the mean national. So that means that our alternative hypothesis is that the mean town average is either greater than or less than $150. So you can see how this one's a little bit different, because typically we've been doing, oh, this is our null hypothesis and we're going to assume that it's greater, or we're going to assume that it's less than. So this is why we're different. So this is why we're using a two-tailed test. And two-tailed just means not equal. Okay, so the hypothesized mean is $150. And so now we're going to sit there and we're going to test our hypothesis at whether or not we are not going to be equal to $150. And we're going to come up with what our confidence interval, not our confidence interval, sorry, what our p-value is, so we can say that. And so the first thing we got was sample size. I'm not going to recalculate it. I'm just going to drag this stuff down from here, because we've already done it. And that's why I've left the names in there, because I do want to keep using the same names. And so we've got our standard error of the mean. So what is our standard error? Standard error is going to be the sample standard deviation divided by the square root of our sample size. And I'm grabbing them up here because they're the ones that have the range names put in there. So our standard error is 2.3. And then now what we're going to do is we're going to have to test our t distribution. So we're going to have to calculate out our t value. And so we've got a difference here. So we're going to test our sample mean minus our hypothesized mean, and then divided by the standard error of the mean. So that gives us a t-value of 3.899. Degrees of freedom, we've just got the one set of data, so that is our sample size minus 1. And so our p-value. So we are running different tests, once again, because we've got a two-tailed t-distribution. So we're going to do a t-distribution two-tail. And we're actually going to finish writing that out instead of just hitting enter so it works. Okay, and so now what we want to do is we want to look at the our t-distribution value. And so what we've got is our, if we look, our x value, which is going to be 3.899 times our degrees of freedom. Well, not times our degrees of freedom, but with our degrees of freedom. And now if we close that out, we're going to get a very, very small value. But before we analyze that, I just want to point out something that because of the way our sample mean is and the way we calculate things, this could end up being a 0 for our, this could be a negative number, which would cause a little bit of problems within a t-test. And if that ever happens, the way that you could fix it would just be go and say, give me the absolute value of this. But we don't have that issue with this one. So as I look at it, let's look at my p-value. Look how far I have to go out. And once again, that's a percentage too. So we're not in the 10%, 5%, or 1% confidence interval at this point. We're at the 0.01 confidence level. So with that level of p-value, so a low p-value. Now once again, typically, especially from on the science side, we're usually looking at 0.05. If it's 0.05 or less, we're like, okay, that's good. But this shows strong evidence to reject the null hypothesis. Hypothesis. And so that's, H0. That's our null hypothesis. And so basically we have the sample evidence shows that there is statistical evidence to support that the town grocery bills are significantly different from the national average. All right, that was a fun one. If you have any questions, please let me know. If not, I will see you next time.